Hello student. So today's session is basically the revision class for class 10 ICSE and class 12. So for this class, I am taking those who already is under revision for the coming board exam, and you know that whenever you are doing revisions, you have to learn the recalling, like how to recall the concepts, and that's really helping you before faster revision before the exam. Okay, so today I will explain you briefly about the Faraday's law of electromagnetic induction. So before going to that, so two things you already know, that is the electricity and next is the electromagnetism. We know that whenever there is a flow of current in a circuit, in a coil, so there is a magnetic field produced, right? So flow of current, whenever there is a current is flowing in a circuit, in a coil or in a conducting wire, so around that the magnetic field is produced. Okay, so that is a part of electromagnetism. And what is the major application of electromagnetism? That is the electromagnet, like the solenoid. We know that solenoid, there is an electrical coils where we are uh, passing the current and we received a the temporary magnet. So that's the electromagnet. Now magnet means what? Magnet means it's a field, magnetic field, and this is presented by magnetic field lines. Let's say I am having this magnetic field. So these are the magnetic field lines. Magnetic field lines, and we are using the symbol B for magnetic field. Okay. Now next I will explain you the magnetic flux. So what is magnetic flux? Magnetic flux means what? Let's say we have this magnetic field and a coil is there. Okay. So this magnetic field will pass through this coil, okay, and we'll get the magnetic flux. So that is phi is equal to BA cos theta. Phi is equal to BA cos theta. So what is A? So area, this is the area of this particular wire, okay, and this cos theta, the angle between the magnetic field and the this particular coil, okay, a particular conductor. So what happened, this angle is very important. Now for this conductor, so the vector will be like perpendicular to this, okay, this will be the area vector, right, and this will make an angle with this magnetic field lines, that will be theta, that will be theta. So this is very basic part of this. Okay, now I'll explain you the Faraday's law of electromagnetic induction. Now let me show you. So what happened, that whenever there is a change in magnetic field, we are receiving the induced EMF. So electromagnetic induction. That means what? That electricity or EMF produced due to change in magnetic flux. So we are receiving the induced EMF due to change in magnetic flux. Okay. So whenever we are receiving the induced EMF, we will receiving the induced current. So this is the central idea of Faraday's law of electromagnetic induction, that whenever there is a change in magnetic flux through a conducting wire, so there will be an induced EMF. Okay. Now how does this change in magnetic flux happen? How does it happen? Let's say there is a conducting wire I have. Now if I am taking a magnet near to it, let's say this is a north pole, this is a south pole. So what is the property of a magnet? Magnet is producing magnetic field lines, right? Magnetic field lines. So they are starting from north pole and ending in the south pole. Again, they will move like this. So these are the magnetic field lines. So whenever a magnet is going very closer to a conducting wire, what happen? The magnetic field exposure will happen through a flux. So this flux is going towards the coil. Okay. So if this magnet is approaching there, what happen? There will be a flux exposure will be changed. So flux exposure will be change means there will be a change in flux on this particular coil. So whenever there is a change in flux, a current will be there, because change in flux will produce induced EMF, and induced EMF is producing current. So how to understand about that current? So if I am having a, let's say I am taking a galvanometer here, okay, this coil. So what happened? This galvanometer will show a deflection whenever there is a change in magnetic flux. Now question is, what is galvanometer? Galvanometer is a device which is helping to detect the current. Inside galvanometer there is a magnet and the coil. Whenever current is passing through this circuit, so this the galvanometer will receive some deflection, and we understand, yes, a current is producing in a circuit. Okay. Now, so this magnetic flux, whenever there will be change in flux through this coil, so we will receive a EMF. Now, what are the process of change? What are the options? One is that this pole is going very near to the the conducting wire. Another will be that this magnet may go away from the coil. Even there also the induced EMF will produce. Or what happened, that strength of the magnet we can increase. You know that flux, what is the mathematical expression of flux is BA cos theta. So this flux will be changed by increasing or decreasing the magnetic field, by increasing or decreasing the area, and theta is the the orientation between the axis of this the flux and the axis of this coil or the conducting wire. Okay. So these three parameters are responsible for changing the flux. So by changing these parameters, I can change the exposure on a coil, magnetic field exposure, and I will get the induced EMF. Then I will get the induced current. Okay. Now, so this is about the Faraday's law of electromagnetic induction. So part of this, there is an change in flux happen. Let's say flux change from phi 1 to phi 2. Okay, so change in flux will be phi 2 minus phi 1. Now rate of change. Okay, this is the rate of change. So induced EMF will be equal to the rate of change of the flux. Rate of change of the flux. Okay. So this is about the Faraday's law of electromagnetic induction. Now, there is one more law. Okay. The Lenz law. So what Lenz told? He told that whenever there is a current is producing, this induced current will oppose the cause for which it is produced. For which it is produced. Okay. So Lenz law basically, it's supporting the conservation of energy. Okay. So that's why now for supporting Lenz law, we are giving a negative sign over here. That means this rate of change of flux is opposing the induced EMF. Okay. Rate of change of flux is rate of change of flux is proportional to EMF, and also that the induced EMF or induced current will oppose the cause of its production. So let me show you what does it mean. What does it mean? Okay. So let's say there is a coil. There is a coil. Okay. And we are having the magnet, this is north pole, this is south pole. If this magnet is approaching toward the coil, so there will be induced current. Now what happened that, so there should be a repulsion, there should be a repulsion. How does it happen? Whenever there is an induced current, so there will be a there will be magnetism, because you know that whenever the current is flowing in a circuit, so it's producing magnetic field. That means we'll get some magnetic poles. So it will having the north pole here in this coil. So this north pole and north pole will repel each others. So there will be repulsion. So whenever this magnet is approaching toward the coil, so in this coil there will be a temporary magnetism happen, and the north pole will be producing here. Okay. Similarly, if we are taking this magnet away from the coil, what will happen? We'll get the south pole here. Okay. Now north pole means what happened? That current will be producing in the anti-clockwise. Whenever this magnet is approaching toward the coil, okay, the current will be in the anti-clockwise. So anti-clockwise rotation current means, so the north pole will be there, right? And whenever this magnet is going away from the coil, south pole is produced, because the current will be producing in the clockwise directions. Okay. Okay, so that's it. I think just this is for a brief, session for revision. In the next class, I will come with the, alternating current, like AC, the mechanism of the AC motor. Okay, okay. Thank you.